All right, I'm Benjamin Cabanes and I'm on the NX Core team. Today we are going to talk about monorepos. I'm here to introduce the concept, the situations, and break down some misconceptions about monorepos.
And I'm Philip Fulcher. I'm also on the NX Core team. I'll be back in just a little bit to answer how we can use NX to manage our monorepo at scale.
So, why do companies, big and small, like to manage their code on monorepos? Or in other words, having a single code base to manage multiple projects? The short answer is that it helps manage complexity by applying best practices organization wide. It gives consistency and predictability in your code while also encouraging code sharing between projects. So that was the short answer. Now, for the longer one, this is what this talk is about. Okay, so first, we need to define what we mean when we talk about monorepos. At Narwhal, what we think is a good definition is a monorepo is a single repository containing multiple distinct projects with well-defined relationships. The first part is pretty easy, and this is usually what everyone is thinking about monorepos. Though, as always, this is a little bit more complicated than what it seems. The well-defined relationships are what will make all the difference between a failed implementation and one that scales with your organizations. Putting all your projects in one repository is the first step towards a monorepo. It gives us a high-level view of all the projects because we have access to the whole code base. It helps us see which pieces of code can be easily shared between projects, but also reusing CI setup and already available tooling. It enables collaboration. Since we have access to multiple projects, we need to have structures in place and processes to enable communication between people. We need to share common definition, best practices, and architectures. It makes us remove assumptions, like what are the dependencies on a specific project. Since we have all the code at the same place, we can follow the dependency tree. We can also start and run the project directly from where we are and see how our changes are affecting the target application. No need to deploy or publish anything. The well-defined relationships allows us to structure the code in different units. Projects are divided into multiple chunks that can be categorized by intent or type. This makes it easier to think about the pieces composing our projects and allow us to quickly and identify where we can optimize and reuse code. Like having a shared models library consumed by a front-end and a back-end application, or a design system that implements the company UI elements, for example. Having encapsulation and well-defined API between these units of code will help us avoid building a monolithic application. The fact that monorepos tend to have a bigger amount of code than polyrepos or multi-repositories creates a common misconception where people think of monorepos as monolith. But monolith and monorepos are very different concepts, where monorepos are about code organization, while monoliths are about code linking and a particular type of deployment. We can have multiple monoliths in a monorepo, like we can have micro frontends or microservices in a monorepo as well. In a multi-repo setup or multi-repository, we tend to have a distribution of monolith because we have one project in the repository. We do not necessarily think first about the modularity of our application, thinking about divisions and encapsulations. We also tend to have a single deployment per repository. With the monorepo setup, the structure present makes us intentional about where we place the code, how we are consuming and deploying it. Relationships between projects are really important, specifically what type of relationships we have and what we can do with them. In a monorepo, this organic growth of both code and relationships will pass a threshold from which individuals like you and me will have a hard time to keep track of everything. Code will be duplicated and collaboration will suffer. This is why tools are so important in Monorepo. We need automation and developer assistance to continue evolving the Monorepo alongside the organization. Having a tool creating what we call a project graph is crucial for the developer experience and the amount of assistance we can get out of the Monorepo. The more assistance we get, the easier it is to use a Monorepo. A Monorepo tool understanding relationships is key to first creating this internal project graph, which is a representation of the relationship between projects. From there, we can use it to make dynamic, powerful, and easy to understand representations of the current architecture at that moment in time. The project graph makes our processes smarter. When we build, lint, or test, or any other command we run them only on the specific projects affected by our changes. This cut down drastically the time for CI and CD because we never run tests or builds unnecessarily on units of code that haven't changed. The project graph makes cross-project changes easier by showing to the developer all the files importing a specific project and enforcing relations and contracts between them. Use these project graphs to enable smart code generation for complex code updates, for example. Projects, relationship structure, and code organization are more important concepts to monorepos. And the tooling capable of understanding the social contracts and structure of your monorepo is the key. It's what will keep your monorepo performant and optimized while growing. Now that we know a little bit more about monorepos, what's wrong with having multiple repository or the polyrepo approach? Well, nothing's really wrong. It's not the end of the world or anything. It's just that it has a high cost of maintenance and is difficult to scale. Why? In a multi-repository setup, when we want to share some piece of code, things can get quite repetitive. We create the repository and the permissions. We set up CI and CD, set up the tooling, write the shared piece of code, deploy and publish. And that's only for the best case scenario, but how do we test? Well, we need to deploy and publish in order to effectively test by consuming the artifact from a different project repository, right? Whereas in a monorepo, we write directly the piece of code we wanted, and that's it. And since we have access to all the projects, we can test each consumer right now without deployment nor publishing anything. Everything is in one commit or in one PR. Now, what happens if there is an issue with the shared code, like a dependency conflict with it? Well, we need to make the change, redeploy and republish in a polyrepo. And in a polyrepo, it is very repetitive and it can take a long time to get anything fixed because you have multiple deployment publishing steps with multiple PRs, branching schemes, and waiting this time for CI and CD, as well as code reviews on multiple repositories. This is pretty cumbersome and it is not scaling well. We can say the same if we want to do a quick experimentation. It requires dedicated time and a lot of will to go through the hoops of beta publishing a package on a local registry or NPM. Then try to implement something with it in another repository. While on a monorepo, this is fairly straightforward. Our tools are already there and set up. The whole code base is there. We create our experiment or the fix, possibly using existing libraries, build and see if that's working. Another common situation in a polyrepo setup is when we have our application consuming two libraries depending on the same packages, but with different versions. This is called the diamond dependency problem, and this is a really tricky situation and can stall your development process for a long time because of all the steps necessary to fix and to publish a fix for a specific package on multiple repositories. To avoid this problem, a monorepo will tend to have a single version policy where the projects in the repository share all the same versions of every package. The polyrepo setup is supposed to be a simple, quick, and easy solution to follow, but it usually turns out to be a very costly, high-maintenance solution where releasing and publishing features or updates can take days or even months. And because of this, they create silos between teams, and when isolated, it is easier to do the wrong things. That said, having a polyrepo containing a monolithic application is extremely common. So if all this looks familiar, well, you are not the only one. In fact, most enterprises are in this situation. The industry has moved to the polyrepo way of doing things for one big reason: team autonomy. The problem is that this autonomy is provided by isolation, and isolation harms collaboration. Now, why are monorepos better for collaboration? Well, we have all our projects in the same place. We have clear and well-defined relationships with and within each project. So we have auto-documented structure and a code overview with ways to enforce, discover, and use these relationships to power our tools. In a monorepo setup, we get no overhead to create new projects because we are using the existing CI setup and no need to publish version packages if all consumers are in the same repository. Plus, developers follow the same best practices and architectures. A monorepo allows for atomic commits across projects, so everything works together at every commit. There's no breaking changes when we fix everything in the same commit or PR. We can follow the one version policy, so we don't need to worry about incompatibilities because projects depend on conflicting versions of third-party libraries. We get consistent tooling because each project uses the same set of tools for running tests, building, serving, deploying, and so forth. It completely removes any mental overhead of remembering which command to use from project to projects. It is a learn once, use everywhere situation. We also get developer mobility by having a consistent way of building and testing applications written using the same tools and technologies. Developers can confidently contribute to other teams' applications and verify that their changes are safe. Now, some of you are probably thinking, I can't use Monorepo because I do micro frontend. And that's also a big misconception. In a monorepo, we have a lot more constraints and processes provided by good tooling. Having a micro frontend setup in a monorepo allows us to not make any assumptions on other parts we might depend on because we have access to the code itself. It allows our micro frontend to be more manageable and makes it easier, like being able to test our changes without the need to publish anything to make sure everything is working. And having code in one place does not mean we cannot deploy it separately. It actually means it is easier to deploy those units separately if they have to know something about each other. Another misconception on Monorepo is about ownership. Since all the code is in the same place, then everyone has access to it and can make changes to anything, right? In reality, with a polyrepo setup, the shared code usually ends up being in some sort of kitchen sink type of library. All teams kind of co-own it because they need to share through that mechanism, but they tend to do it by isolation, like everyone is looking only at a specific place, doing its own changes, hoping it won't affect anything else. Whereas in Monorepo, we have actually well-defined items for sharing, so there is more structure, there's more control over what goes where. There are tools set up to enforce the boundaries of code usage and guide developers by making them aware of what is the contract and what is possible to do with each type of project in the Monorepo. We can clearly see the boundaries and look over to understand how our changes affect or not the surrounding code. It helps understand the big picture and gives us a higher confidence our code will not have unwanted side effects. Again, project relationships and automation are key to monorepos. Hence, the ability to use, create, update, and perform any action with these relationships will determine the complete developer experience we will get out of a monorepo. Your monorepo tools are extremely important. They need to give you these project relationships layer, but also need to enable developers to navigate and understand easily all the social contracts present in the monorepo. They need to be the monorepo assistant to the developer. And this is what NX does, and it does it beautifully.
Thanks, Ben. So Ben just told you about what monorepos are, and I'm here to show you how NX is the right tool to manage your new monorepo. So let's talk about code co-location. Ben's already told you how if you just dump all your code in a single repo, you're headed for a spaghetti mess. You need a way to organize and isolate your code for a monorepo to work. NX solves this problem with projects and the project graph. By breaking your code down into smaller, isolated units and understanding the relationships between those units, we can help you organize your code better and perform actions like building, testing, and linting on just the parts you're focused on at the moment. We can also visualize your graph so that you can understand the relationships in your code base better. A project in an NX workspace is an encapsulated unit of code. There are two types of projects: applications and libraries, or apps and libs for short. Apps are the main entry point for a runnable application. This is something you're going to deploy to some sort of environment for users. They depend on library projects. Library projects are isolated units of code. They can create features for apps, they can be shared code for multiple features, or they can be buildable packages on their own for distribution. They contain related code and can be as granular as you like. Each lib has a name, a path alias, and a well-defined API. The name is an identifier that also describes to consumers what it's used for. We recommend that users incorporate some short keywords in each library name to help identify its contents. For example, libraries containing presentational components should contain the word UI, something like cart UI components for the presentational components for your cart. The path alias gives developers an easy way to import that library. Your workspace has a root alias that starts with an @ sign, something like @myorg. When consumers import that code, they import from the alias @myorg/cart/UI components. No one has to deal with annoying nested directories when importing their code, and these aliases are built using TypeScript. Your IDE is going to be able to pick them up and auto-import them from the correct alias for you. The project itself might have any amount of code internally, but it exposes only what it wants others to depend on. This is its public API, and it's defined in the index.ts file at the root of every lib. The workspace will show a lint error when other apps and libs try to import something that's not available on the public API of that lib. Projects give you a way to organize your code in a predictable way and expose only what you want to from that code. This gives you the same isolation that you had before in a polyrepo, but in a much more convenient way. So NX not only helps you organize your code, but it also helps you define the relationships between those projects. Using ESLint rules, we can dictate which relationships are allowed to exist between different projects. Projects can provide metadata in the form of tags that can give the project graph more information about which projects are allowed to import others. For example, if you have both front-end and back-end apps in your workspace, you want to have some control over what code is shared between the two. You want shared API interfaces to be imported by both of them, but you don't want your React code importing your Express code. By tagging these projects with a tag, we can then use module boundaries to enforce that these relationships are upheld. Ben talked about micro frontends and monorepos, so let's put these concepts together to illustrate how NX makes your micro frontends easier. You want a micro frontend to stand on its own as much as possible, and you need a strong understanding of how it communicates with the shell or other micro frontends. By organizing our micro frontends into projects and dictating which projects can depend on others, we can have confidence that our micro frontends don't directly depend on each other. We do this by tagging them appropriately and configuring the module boundary between them. Without this module boundary, it's way too easy to accidentally import something from the wrong place. Now you can learn even more about building micro frontends using NX during Column's talk, Superpowered Micro Frontends with Monorepos. NX has helped you organize and share your code, but now we're going to make day-to-day development faster. And that happens in 3 ways: project targets, affected commands, and caching. Projects have targets, which are actions that you can perform on that project, such as building, testing, or linting. You probably already have things like this defined in NPM scripts, but targets are all granular per project. You can define both the targets themselves or the configuration for a particular target on a project-by-project basis. Now that means I don't have to build or test every application or package in the workspace when I'm working, just the one I'm working on. I can also use the run mini command to run the same command for multiple libraries at a time. These targets help you run a specific slice of the workspace that's important to your current work. Let's take a look at running unit tests using targets. You may have one or more unit test runners or frameworks in use at your organization. You can configure the targets for each project to use the correct executor for the tests in that project. An executor in NX is just a sort of task runner. It gives us just enough information to be able to run what you need to. You may also have some global unit tests set up that can be configured at the root level of your workspace. Projects can then have their own configurations, which add additional definitions that are specific to the needs of that project. So while you can encourage consistent tool use and configuration at the global level, teams can also have autonomy at the project level to customize things for themselves. We have projects, which are isolated units of code, and we have targets, which are tasks that we can run on those projects. And we have a project graph, which understands the relationships between projects. By using all of this information, NX can determine which projects are affected by your changes and run targets on those projects. This is the affected command, and it can be used on any target in your repo. The affected command will trace the project graph to see what projects have been impacted by our changes, and then run a particular target for all of the impacted projects. We can use this to detect when we've caused problems. We can run affected test to run all of the unit tests of impacted code to see if they still pass. Affected build will see if any app that depends on this project still builds. And affected E2E can be run to build and test our end-to-end processes. NX helps us to not only run the processes that we need, but it can also help us to only rerun the processes that we need. NX has computational caching built in. Results from most targets can be cached, build, test, or lint, for example. And NX won't rerun them unless it's detected a change that impacts that project. So if I run the test target for a project, if I run that test again without making a change, the results will be fetched from the cache instead of actually rerunning the tests. And with NX Cloud, our remote caching service, that cache extends out to the cloud. If one of your coworkers or CI has already run those tests and you haven't impacted them, the test results will be pulled down from the cloud. This is great for reviewing PRs. If you pull down a branch that's already had tests or builds run by CI or the author of the PR, you'll get those cached results. No need to run in anything on your machine. Johanna is going to talk to you more about NX Cloud during her talk, Into the NX Clouds. By having all of our code in an NX workspace, it becomes easier to make atomic changes. As Ben told you, this means to make a change in a piece of shared code, see how it affects the consumers, and change the consumers to adapt to the change. First, before we make a change, let's see how many other projects depend on the project we want to change. By bringing up the project graph and focusing on that project, we can see exactly what the upstream impact will be. We can even see how much coupling there is between the two. Are there a lot of files involved in the edges between projects, or just a few? If we're comfortable with the impact, we can make the change in the project. Well, how do we make sure that that change is good? Well, we use our affected commands. If there are problems, you can change the consumer code in the same PR using the same affected commands to understand the impact. By the time you're done, you have a working code base in one PR, rather than multiple PRs and version deployments spread across multiple repos that may or may not work at any given point in time. This process is also helpful for quick experimentation. Let's say you want to make a change in your design system, but you're not sure how it might look in the places where it's actually used in your applications. You can make that change, run your applications, and see. There's no packing and publishing beta releases, there's no fiddling with a finicky NPM link, and everything's right at your fingertips. NX helps you understand how a change might impact your code base, but it can also help you develop that change even faster with generators. Generators do just what the name suggests. They generate code for you. And it isn't an automated copy and paste. The generated code can actually be customized by the options in the schema for that particular generator. Generators are provided by each NX plugin, and they cover a variety of use cases. There are generators to create new Angular apps or React apps. You can add Storybook and Cypress to your front end, or you can create smaller things. Generators can create new components, libraries, or routes. We've even got generators to take care of setting up your micro front end in Angular, with a React generator coming soon. Custom generators can also be written for your own workspace. You may want to set up new libraries in a particular way. Make sure they use the correct style framework, use the same test runner, or have appropriate tags. Using the same dev kit tools available to plugin authors, you can create these generators by composing other existing generators together or writing them from scratch.
So what are the key takeaways today? First, we saw that monorepos are not just about code collocation. The well-defined relationships between isolated units of code are essential. We need good tools and automation to scale our monorepo alongside our organization. If you want to know more about monorepos in general, we maintain a site discussing the topic and comparing monorepo tools at monorepo.tools. This is an open source project that accepts PRs from any other team building a monorepo tool. We are happy to see monorepo field pushed forward by so many different tools.
On the NX team, we're really excited about monorepos, and we're passionate about providing the right tooling to give you the best experience. If you want more details about what we've talked about today, visit our docs site at nx.dev. You'll find guides and tutorials for getting started with a new workspace or converting your current repo into an NX workspace. We've also got the rest of the comp full of great talks, and you're not going to want to miss any of them.